All right, in our last video, we started working on what will turn out to be the longest proof that we've written so far in these videos. And we've just gotten started with it. And we really, in one sense, we haven't done a lot at all. In the other sense, we've set up a really good skeleton that we just need to flesh out in order to finish the proof. So let's see how we can move on to some next steps. So we started out with the given statements and what we need to have at the end. And so we had this really big gap in the middle that we needed to fill out. And what we managed to do is we managed to say, you know what, these two triangles are going to be really important in our proof. So somewhere in the middle, we're going to wind up proving that those triangles are congruent. So now instead of having one enormous blank gap, now we have two smaller gaps. So let's see if we can start to fill in those smaller gaps. So let's try and prove that these triangles are congruent. Okay, and once again, when we're proving triangles are congruent, we need to know three facts about the sides and angles of those triangles being congruent. And when we do that, those facts that we come up with are going to justify one of our triangle congruence theorems that were in that handout that I gave you last week. So let's see, we've already got one triangle congruence, or one side or angle congruence here. We know that AB is congruent to CD. So those are sides of our triangle. If we can find more things, then we're going to be awesome and done. So what else do we know about these triangles? About the parts of these triangles? Well, do we know things about the sides, or do we not know anything about those sides, other sides being congruent? It turns out that we don't know anything about those sides. Here's how I know that, just to give you a sense of where my gut is coming from. I need to prove that E is the midpoint of AD and BC. Okay, so I need to prove that E is the midpoint of AD. What does that mean, that E is the midpoint of AD? If E is the midpoint of AD, what two lengths would have to be congruent to each other? E is the midpoint of AD, which means the distance from E to A is the same as the distance from E to D. So that means that AE is congruent to ED. So there's nothing in the givens of the proof that tell me that, but I'm going to need that down at the bottom. But this is cool because if I knew that these two triangles were congruent, I would be able to conclude that these two are congruent to each other, wouldn't I? Because if these two triangles are the same size and the same shape, that's what congruent means, these two sides would also have to be the same length. So that is going to be a consequence of that triangle congruence right there. AE is congruent to DE. And what's my reason for this going to be? I'll give you a hint, and this is something that you can take to the bank. Once you've proven that two triangles are congruent, anything you're talking about afterwards, talking about the sides or angles of that, is because of this reason called CPCTC. And that means just what I said before. If these two triangles are the same side and the same shape, you can imagine rotating this 180 degrees. When you do that, this side and this side line up with each other. And because these two triangles are the same size and the same shape, and those two sides line up with each other, they've got to be the same length because they're corresponding parts of those two congruent triangles. So they must be congruent. We also need to show that E is the midpoint of BC. That's almost the same thing as AD. So what other statement am I going to write talking about congruence that makes me say that E is the midpoint of the line segment from B to C? Well, for that, I'm going to write almost the same thing. BE is congruent to CE. Once again, that's also going to be because of CPCTC. All right, so when I prove that these two triangles are the same size and the same shape because of that 180-degree rotation around the center, and if I do that, those two diagonal lines line up with each other, that means they have to be congruent. So if I know AE is congruent to DE and I know that BE is congruent to CE, what makes me be able to say that E is the midpoint of both of those line segments? Well, I'm really just saying the same thing I said here, aren't I? All I'm doing is saying if E is the same distance from A to D, and if all those points are the same line, are on the same line, then that just means E is the midpoint of AD. So the only thing I'm using there is the definition of midpoint. Okay, so I'm taking these congruent statements and I'm just expressing them in human language using the vocabulary word midpoint. And so I'm allowed to do that because that's what midpoint means. You've also seen us being able to work from this as a given to these congruent statements, also because of the definition of midpoint. Okay, so at this point, we've really got a really solid skeleton of the proof right now. We had these two gaps, but we've just filled one of them in. We've got a lot of gaps left in the proof, but just figuring that amount out, we've moved from 1 point to 2 points. Okay, so that's great work. We've been able to figure out what we know and use it to climb the way up that ladder. And you don't need to make it to the top of the ladder to be successful at doing proofs. If you can just make it one rung up that ladder, you've done something to be proud of. But there's no reason to stop there. Let's see if we can figure out how to become strong enough that we can climb all the way to the top of that ladder. And that's what we're going to do in the next step.